Hi viewers, in the present class we will start traffic engineering preparation for gate, in traffic engineering we have three basic parameters: speed, density and volume. You can also call as flow. Speed generally denoted by V and density by K, volume by small q. We have different types of speeds. Before that, basically what is speed? We'll see. So in a stretch of road, so this is a road and an observer is standing here who counts the traffic, speed and all. At this point he is noting down the spot speeds, generally in kilometer per hour, right? So what are the different methods of measuring speeds? We can use speed guns that you might have observed. They are with the traffic police. They use guns, or you can use loop detectors which are installed along the road, beneath the road surface. So loop detectors, or we have so many other detectors also, like acoustic detectors. And generally for student purpose and for academic purpose we use enoscope. It is a simple setup of a wooden block. This is the front view. If you see from the top, it will be like this, and there is a mirror here, and they will install enoscope here, and the view can be viewed from the right angles also. Here suppose another person is there, you just note down the time span between these 2 points, and that would be considered as spot speed. Now generally we need relationship between speed, density, volume, speed and volume. We will see that. Before that, density. How to determine density? Suppose there is a stretch of road and there is traffic, lot of vehicles are there. Suppose we have taken some aerial photograph of this particular road, then we can count the number of vehicles and we can convert it into vehicles per kilometer. So that's how we determine density in general. And flow. So as we are collecting the spot speed data here, we must be knowing the number of vehicles that have passed this particular location. So that is passing vehicles per time. Generally we take it as our vehicles per hour, kilometer per hour. So in general, vehicles per hour, vehicles per kilometer is not the right one. In place of vehicles, we use passenger car unit. Means each vehicle is having different measurements. So we have two-wheeler which takes small space on the road, and we have three-wheeler, and we have cars, buses and trucks, and there are different types of trucks. Everything should be converted into an equivalent, into same unit, that this car will consider as one PCU. And in terms of cars, we convert all these other vehicles, that is two-wheeler you can take it as 0.5, three-wheeler auto rickshaws, this is 0.8, buses and trucks we can take them as 3.5, and other vehicles are there, that is mini buses, long trucks and all. So we have different equivalents, that is same units for all the vehicles. So you convert these vehicles into PCUs in terms of PCUs and use it. But for simplicity, we are leaving like this. We are writing in vehicles per kilometer, the units, and vehicles per hour also. I will see relationship. Before that, we will discuss density and volume. Suppose similar thing, there is an observer here who takes data regarding vehicle to vehicle, what is the space gap, means from last bumper to this last bumper, what is the space gap from aerial photograph or by counting using CCTV cameras or video cameras. We are counting the lengths. We already marked the lengths on the road, and then we have captured the video of that particular location, and we calculated space gap, that is called space headway, between successive vehicles, say S1, S2 up to some Sn, and we have taken average. So average of all the spaces between vehicles, that is space headway. We call it space headway, and the units for space headway is generally meters per vehicle. Meters per vehicle, and if you take inversion of this 1 by space headway, we get it in vehicles per meter. You see, this is the units of density, and you convert in vehicles per kilometer, that is 1000 divided by space headway is the density. Got it? In vehicles per kilometer. Similarly, we will see time headway. Time headway simply headway, which means the time gap between vehicles. Now, earlier we have seen space gaps. Now we will measure time gaps between successive vehicles, that is T1, T2 and up to N vehicles. And we have taken average of those N vehicles, time gap in seconds per vehicle. Right? If you take inverse of this, we will get in vehicles per second. If you see, observe here, vehicles per time is the unit of traffic volume. Now you convert in hours, you get 3600 by average time headway, you get flow or traffic volume in vehicle per hour. So now we know now speed, density and volume. Briefly, we know. Now we will see relationship among these three parameters. Right? First we'll see speed, density. So kilometer per hour and vehicles per kilometer. We assume linear relationship. In actual, this is not the case, but for simplicity, as per Greenshield's model, we assume, and if there is hardly any vehicle, means there is only one vehicle per kilometer, say, then there is no restriction regarding speed. This vehicle can travel with whatever speed the driver wants, and that speed we call it free flow speed, denoted by Vf. And there are huge number of vehicles in a stretch of road, that is density is very high. Then what happens? Traffic jam happens at early hours in the morning, whenever the vehicles travel to schools, colleges and offices and all. We have traffic jams in the morning and evening, and this density is called jam density, denoted by Kj. Say Kj. Now we have V here, K here, and we have jam density and free flow speed. Now see, speed and flow, that is volume. As the volume increases, the speed will decrease, and there is one point where you get maximum flow, that is capacity of that road. So speed goes on decreasing as the flow increases, and at one point flow will decrease and speed also will decrease. Flow will decrease and speed also will decrease, and this point is called traffic capacity or maximum flow, this one, and you can denote it by Q max. Similarly, we will see the relation between density and flow. As the density increases, flow also will increase up to one point, and again this happens. In this parabola, you can see this is the free flow speed, and this parabolic curve, you can observe this is the jam density, and we have maximum flow here. If you interpret these three, this is half of the speed, right? Vf by 2, you get maximum capacity. And similarly, half of the jam density, you get maximum capacity. And there is an equation, Q is equal to K into V is the basic equation. The product of density into average speed of that particular road. Now if you want to get Q max, so Kj by 2 to Vf by 2, this can also be derived, but we don't want the derivation. That's why I have explained you in a simple way. Kj into Vf by 4 is the maximum flow or capacity of that particular road, that is in vehicle per hour. Now is it clear the relation among these three? And from this equation you can write a simple equation. K is equal to, if you want K, that is Kj into 1 minus V by Vf from this linear curve, from this linear relationship. Similarly, V also can be written as Vf into 1 minus A by Kj, Kj minus Kj by Vf into V. You can write it like that also, where Kj by Vf is the slope. Got it? Similarly this thing. And if you want Q, multiply these two. So for a given point where you have K and V, these equations can be used to find K and V, but you have to know any one point. For this point, this can be determined. For this point, this can be determined, as we know the free flow speed and jam density. Is it clear up to now? I will rough all this thing. We will see different types of speeds. Density, volume and all we have seen. Different types of speeds. Technically we have two types of speeds, that is space mean speed and time mean speed. As the name itself suggests, there is a space of length L and we have vehicles traveling at different speeds. In this space, we are calculating the times taken by each vehicle to clear this space L. Then space mean speed, Vs, can be written as NL by sigma 1 to n. Now you can take, we are taking average. If you see n vehicles, L is the distance, and Ti, sigma Ti is the sum of all the times. Now I'll write it like this. I've taken this L into the denominator, which will give you n by sigma 1 n, and inverse of time by length is the inverse of speeds. L by T, you get speeds, and this is harmonic mean. Harmonic mean of speeds of all the vehicles in this stretch. This is harmonic mean. Now you will see time mean speed. As the name itself suggests, we are taking spot speeds. Directly we are measuring the spot speed at a particular time gap, and here we are calculating speeds of all the vehicles crossing this particular area. Suppose V1, V2 up to Vn is the speeds of all the vehicles. Now Vt, that is time mean speed, can be directly given as directly taking the average of the speeds of all the vehicles that have crossed this location, which is the arithmetic mean. Arithmetic mean of speeds. If you want relation between time mean speed and space mean speed, that can be derived, but we don't want the derivation part. Vt can be given as Vs plus sigma square by Vs. So space mean speed plus variance of these speeds. This variance, you know, right? Variance V average is Vi whole square. So sum of the difference of the each individual vehicle and average of all the vehicles divided by n, which gives you variance. This is variance. If you can't gather this, recollect this, you can see statistics where you will get this variance and all. Now space mean speed and time mean speed is over. The next topic we will see in the next class.